Hello class, this is lesson 4-2 in your textbook titled How to Apply Congruence of Triangles. And let's just talk about what congruent triangles look like. They are two geometric figures that are congruent if they have exactly the same size and shape. Exactly the same size and shape. Okay, and this goes for any congruent figure, but for triangles specifically, they might look like this. I'm going to try to the best of my ability to draw for you some congruent triangles. Typically, we really need to measure them, okay, but just imagine that these are the best of my ability and that these are exactly the same size and exactly the same shape. Whereas ones that are not congruent differ. So I might have a really small one like that. I might have a really big one that almost looks like it's the same type of shape, but it's way bigger, or something that's completely different. Okay, so those are the difference between congruent and non-congruent. So in a triangle especially, you need to notice that corresponding sides and angles are congruent. So corresponding sides and angles are congruent. And what I mean by corresponding is matching. Okay, so that's what we're going to be thinking about today. So, how to write a congruent statement for triangles. Right here I have two triangles drawn for you already, and a whole bunch of labeling that I already did. So you can see in this triangle, it's titled A, B, and C as its vertices, and the second one is F, E, and D as its vertices. And I did some color coordinating just to show you what's kind of matching or what's corresponding. Because here we can see that this length from A to B has a single marking on it, and so does F to E. It has a single marking. That means that the lengths of those are equal, that they are congruent segments. Same with, let's say, angle C and angle D, how they both have three little arches on them. That means that those are corresponding angles, that the angle measurement, they're equal. So first, if we're just going to write a statement, it's very, very critical that you list the corresponding vertices in the same order. So the first statement that I would write is that triangle ABC is congruent to, well, let's look at what's matching. From A, it's congruent to F. So congruent to F. B is congruent to E, E, and then C is congruent to D. So that's one way that I could write a congruent statement. This might be something that you're asked to do, but there's other ways to do it. I could start with, let's say, C. If I said that triangle CBA was congruent to the other triangle, it's very important that you write it in the same order. So since I started with C, I'm going to look to see where its corresponding angle is, and that's D. D, B corresponds to E, and F. And there's many other ways that you could write this congruent statement. Now, some other things that we need to list are its corresponding angles and also its corresponding sides. So the first thing that we see for corresponding angles is that A corresponds to F, which means that angle A is congruent to angle F. That's what that marking means. Also, angle B is congruent to angle E, and angle C is congruent to angle D. So that's it for our corresponding angles. Corresponding sides, we're looking at the markings of the sides. So here I can see that the segment AB is congruent to the segment FE. All right. The next one that I see is BC, which is congruent to ED. And the final one, AC is congruent to FD. And this is going to be really important later on, that if I can prove that these corresponding angles are congruent to one another and that the corresponding sides are congruent to one another, then that should prove that the two triangles themselves are congruent to one another. So let's move on. In this picture right here, I have an example, and I'm told that DEFG, so that quadrilateral, is congruent to the quadrilateral SPQR. Again, we said how important it is for us to realize the order that things are written in. So first I'm going to find X, and then I'm asked to find Y. So let's look. Where do I see these variables? Oh, they're both over here. This one has a Y and an X in it, and it's labeled as one of the degrees for the angle measurement, but this other one only has an X in it for the length measurement. So I think that that's what I'm going to start with, okay? It's starting with the 2x minus 4. And this is from Q to R. So I'm looking up above, and Q to R is right here. And what does it correspond with? Well, I'm going to look at the order it's written. It corresponds with the length FG. So I know that FG is congruent to QR, which means that the lengths themselves are equal to one another. So what is the length from F to G? It is 12 feet. And what is the length from Q to R? It is 2x minus 4 feet. If I add 4 to both sides, I get 16 is equal to 2x. And when I divide both sides by 2, I'm going to find that x is equal to 8. There we go. I solved my first part. So then when I'm looking over here, I know that I can automatically plug in that x in this 6y plus x. Okay, so really now it's 6y plus 8. And what angle does angle Q correspond with? So let's go back to what we're written. Q, it looks like, corresponds to angle F. So I know, just from what I'm told in the beginning, that angle F is congruent to angle Q, which means that the measurement of angle F equals the measurement of angle Q. And the measurement of angle F is 68 degrees. So 68, measure of angle Q is 6y, and now I'm going to replace, instead of the x, I'm going to replace it with 8. If I subtract 8 on both sides, I have 60 is equal to 6y. And when I divide both sides by 6, I'm going to find that y is equal to 10. And I'm done. So using this information on corresponding angles and corresponding sides in different figures, this is a quadrilateral, the ones we had before, those were triangles, I can easily find some missing information. All right, let's move on. We have a theorem right here. It's theorem 4.3, and it's called the third angles theorem. Okay, let's read it. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So in this case, when I'm looking at it, it looks like from our markings that angle A is congruent to angle D. So if angle A is congruent to angle D, and also it looks like B and E are congruent to one another. So angle B is congruent to angle E. Then I can conclude that angle C is congruent to angle F. Angle C is congruent to angle F. This is what this third angles theorem is talking about. Okay, if you know that two of the angles are already congruent to one another, the third ones have to be. So let's use that to kind of solve this missing information problem down below. We're asked to find the measure of angle YXW. So YXW, that's talking about this really big angle right here. So what I think is awesome about these things is you can kind of cover up some parts to really look to see what it's asking you to find. If I cover up this section, I'm really just finding this corner angle of that triangle. So keep that in mind, okay? So in this case, I already can see that angle W and angle Z are corresponding angles and they're congruent to one another. So I can see that angle W is congruent to angle Z. That's something that I'm given. And I'm also given that this little angle right here, we can call it YXZ, so angle YXZ is congruent to this little one right over here, angle XYW. So that's something that I'm already given in the beginning. So by the third angles theorem, I know by the third angles theorem, I can see that angle YXW, so this really big one that I already highlighted in blue, YXW is congruent to this other big one. If I covered this up, XYZ, angle XYZ, this one over here, they should be congruent to one another, okay? By the triangle sum theorem, by the triangle sum theorem, the measure of angle YXW is equal to 180 degrees minus 40 degrees minus 35 degrees. The way that I figured this out was if I'm looking at this really big triangle right here, and I found out that since this right here is labeled 35 degrees and it's congruent to this one over here, I have two of my angles and I just need to find my third. So I can subtract the other two to find this third very big angle. And when I subtract that, I find out that it is 105 degrees. And I'm done. Okay. Moving on. Now I have two triangles. They are side by side. So let me show this to you. There we go. And I'm asked to prove the triangle ACD is congruent to triangle CAB. So let's look at this. ACD, so this triangle right here, is congruent to triangle CAB. Okay, it's very important to go in the specific orders. I'm also shown some details of what's congruent in this diagram. I'm given that let's see here, AD is congruent to CB. That's two of the sides that correspond to one another. Also that DC and AB are congruent to one another. I'm also told that this little angle is congruent to this one, and this double arced angle is congruent to that one. That's the only information that I'm given to hopefully prove that this is true. So remember what we did before? We said if we can prove that all of the corresponding angles are congruent to one another and all of the corresponding sides are congruent to one another, then I can prove that this in fact is true. Okay, that's by the definition of congruent figures. So let's go ahead and make our proof. In the beginning, I'm looking at just some line segments, and I can already see that AD is congruent to CB. And also, I'm given that DC is congruent to AB. This was given in the very beginning. Just from the diagram, I could see that. So I need to prove that all of the corresponding sides are congruent, which means that there still is a third side I need to prove, which is congruent, and that's AC, which is actually the same side in both of those triangles. So I'm going to write that AC, and it looks kind of funny, is congruent to AC. This right here is really the reflexive property of congruence. Reflexive property of congruence. Okay? So I'm done with proving that all the corresponding sides are congruent. Let's work on those angles. Let's look at what we're given. So in the beginning, we were told from our diagram that angle CAD, this is the angle with the single little arch, is congruent to ACB. And also the double arched one. So that would be angle ACD, which is congruent to angle CAB. This was given in our diagram. So I only have one more angle to prove, and that is these two outside angles, if I can prove that those are congruent. Well, I know by the third angles theorem that angle D is congruent to angle B. That's what that theorem says. Third angles theorem. Because if I could prove that two angles inside of a triangle are congruent to one another, then the third angles must be congruent as well. And that's all I need to do to prove that triangle ACD is congruent to triangle CAB. This comes from the definition of congruent figures that we talked about before. Okay, so I'm going to leave you with one more thing. This is one more theorem that's going to help us out. Let's see if I can fit it all in here. Here we go. So properties of congruence that are true for segments and angles are also true for triangles. These are things that we talked about earlier a couple chapters ago. So Theorem 4.4 is just combining all those ideas. It's properties of congruent triangles. The first one is the reflexive property. Reflexive property means that for any triangle, if ABC, if I have that, it is congruent to itself, triangle ABC. Then I have the symmetric property. If triangle ABC, this one right here, is congruent to triangle DEF, then I can say it in the reverse order. Triangle DEF is congruent to triangle ABC. And then I also have the transitive property. That's one that you guys like. And it says if triangle ABC is congruent to triangle DEF, and also triangle DEF is congruent to triangle GHI, then I can conclude that starting at the beginning, triangle ABC is congruent to triangle GHI. And that's a lot of information for today, but we're going to be so set for when we come back to class to work on all this information. See you then.